Today, I wanted to talk a little bit about cloud native Java for Spring Boot devs. I was just joking with the guys up front. The person before me, Josh Long, being a worldwide expert at cloud native, talking about Java. This will be a slightly different approach, a little bit more for the beginner in the space. Ideally, providing you some good examples and places to start. But I really want to kind of draw out the value of cloud native and try not to focus too much on the buzzwords. If you're at all familiar with 12-factor, you realize that any talk about 12-factor requires the presenter to add an additional factor. I've taken a different route, though. I'm adding a factor 0. As you know, you start counting at 0. So custom banners. Josh had a really nice presentation this morning showing some of the cool things you can do. But really, they've made it so easy that you should do something. With Spring 1.4, you just have to drop banner.jpg in source main resources. Previously, you could drop any ASCII text file in there. Some examples. It's Homer, the Home Depot mascot, Nyan Cat also, and the Spring Boot logo down at the bottom. All right, so Codebase. This is the first factor. It's important when you're thinking about Codebase that you don't just say, well, my stuff's in Git, we're tracking with version control, everything's fine. There's lots of really dumb things you can do. None of those we do at Home Depot, but they could happen. But the basic thing here is you have one application, one repo. You want to make sure that you're tracking things in revision control. And that if you have shared code, you don't use that as an excuse to have multiple applications that share the same repo. You either extract it into a library that you share across, or you make it a separate service and you can use it as a dependency. This is another one they showed this morning, unfortunately. But this is kind of exciting. I'm using a Gradle example instead of Maven. But basically, you add in one of the many Gradle plugins out there. And then once you do your build, it shows up in the Git info section. So you go to your application/info, and you can see the commit message, the time, the idea, and the user, as well as what branch it was done off of. Not sure about everybody, but this has been a fun thing for us in the past. You're trying to figure out what's in production. This is a fantastic way to see it, and it just happens automatically once you add in that dependency. On a similar note, this is one of those things that happens a lot. Maybe not with the censored out word, but the idea is you've got a developer that's working on something, works fantastically on their machine, and then you go to pull it down on yours, or you put it in a QA server, nothing works at all. Not ideal by any means. So the thing there is dependencies. You want to declare them explicitly, and then take what you need. One of the examples that people use a lot is things like ImageMagick or any other file system type or any other tool that is part of the OS. You don't want to count on the OS providing that for you. You really want to bring that with you. The second piece here is you really want to isolate that relationship between your app and the runtime. So with Spring Boot, we've got the embedded Tomcat or embedded Jetty. And then you have the build pack that combines the release artifact with the configuration and lets you actually run your application. On Cloud Foundry, there's a couple ways you can do that. You can explicitly declare your build pack in the manifest. So I've got a version here. Or you can just leave it up to the platform. So Java build pack, or if you're really crazy, just leave it out altogether and let the platform determine what build pack is appropriate. But as you can see in that somewhat blurry screenshot, the platform produces a release. So it's combining just the jar file you provided with the configuration, and your application runs. The next one on here, configuration. Configuration and credentials, you really want to externalize from your code. This is one of the most important parts about kind of the cloud native idea. You don't want to have to do a new deployment every time you're changing a property. And while you can say you've externalized your config if you put it in a property file, it's a miserable thing to have to do a new deployment, especially if your deployment process is slow and painful, when you could just have that in an environment variable or some sort of CUPS provided service. So you really want to manage those independently for each deploy, but not have it be part of the release. Within Spring Boot as well, lots of good options here. You can see I'm using Spring Security. So for my local environment, I'm using the exact same environment variables, client ID and client secret, that I am in the cloud profile. However, in the cloud profile, I'm making use of Postgres rather than the embedded H2 database. I mean, all that happens somewhat magically. In the bottom right there, you can see a different format for bringing those environment variables. I don't know why this one's not documented quite as much, but it's fantastic. If you've got a VCAP service, you know what it is. You can reference that explicitly in your properties file, and it'll pick it up when you deploy. The other fantastic way to do this, using Spring Cloud Services or your own deployed config server, you add in just a few lines of code, reference the values you want, and you can actually keep your config in GitHub. So it's revision controlled, and it's kind of available completely outside of the platform. This gets even more magical if you use the config server with CloudBus. So in general, you push your change to the config server via the GitHub update or file system update if you use that mechanism. And as soon as you do that, you can call an endpoint on your application, usually /refresh, and that'll pull in the new config. With CloudBus, you don't even have to do that. You can make use of messaging to update every one of the instances of your app automatically when you make that git config change. And finally, not really cloud native, but kind of a random Gradle tip. If you're using Gradle and you're using profiles, you can add a boot run section within your build.gradle. And then from there, when you run gradlu or Gradle, pass in the profile you want to use, and very quickly you can switch back and forth without making any changes. All right, backing services. This is another exciting one. And really the thing here is anything your application depends on for functionality, make sure it's declared as a backing service. Let the runtime bind it, and this is much like I mentioned a minute ago. You really want this to be something that can be detached and reattached without a deployment. Continuing with my Spring security choice, for adding authorization to, in this case, an Angular app, although it's not totally clear, you add a single line adding Spring security. You add a couple lines within your controller, and then as you try to access the Angular app, the OAuth window pops up, and you've got GitHub security right there. And I think that's kind of the meat of the idea behind Spring Boot and Cloud Native is a lot of these things like auth, like they're solved problems. You don't need to do that again. So use your dependency, use an external service, and you can move those around very quickly. If you wanted to use Facebook, if you wanted to use an internal OAuth provider, all those things are just minor config changes within your application and don't require deployment. Finally, build, release, run. So the build very much is something initiated by the dev, ideally creating a release that is done by the platform or a CI tool, and then finally it's run on the platform. And as we talked about before, you've got one build, but many deploys. Bringing us next to process management. This is really important, and we'll talk about it more in scaling, but you really want to have a single process per application. And this is more conceptual process than literal process running on the CPU. You want to make sure it's stateless and shares nothing across other processes. Any sort of sharing between those really becomes something that makes you brittle. And anything you need for data, as we mentioned earlier, be it session caching, blob storage, or a database, should be externalized and captured in a stateful backing service. Again, Cloud Foundry makes this really easy for you. I use Gemfire. You could just as easily use Redis. You can add a dependency for this Spring Boot starter for Gemfire, set up that service within Cloud Foundry, and then use that for all of your HTTP session status or session information. And very quickly move from a place where you've got a single application instance that is keeping that stuff in memory to a stateful Gemfire backing service that all of your instances can make use of. Port binding. This one's pretty simple, but it's also very important. You want to make sure that the port is provided by the environment and fed to the app as part of startup. Your application needs to be self-contained, and you don't want to inject it into an application server. This is fairly basic in Spring Boot. It's really just build pack magic. You could set the server up port if you needed to, and then in Go or Ruby or any other language, it's very, very straightforward. Concurrency, also extremely important. We talked about the process model just a little bit, and I just like this graphic. But you really want to make sure that you're not letting a single part of the application be a bottleneck and that you're forcing yourself to scale vertically. You want to allow your application to scale horizontally and really have each of the processes separated out. which brings us to disposability. When we're talking about scaling out, this really only works if you have the ability to very quickly spin up instances of your application. So if you're doing kind of the old school WebSphere startup process where you have tons and tons of data being loaded into memory so you can quickly access it later, you're not going to be able to scale. Very similarly, on the shutdown, you want to make sure that you shut down gracefully and find a way to either stop accepting new work and complete your tasks, or to push those tasks to some sort of queue for another instance to pick up. One of the things here is really the idea of kind of the crash-only application, where you encounter a failure, you just crash and go back to a known good state. This simplifies a lot of the logic and really allows you to make sure you can start up quickly and behave properly in a complex environment. So within CF, depending on whether you're using PWS or Cloud PCF within your data center, you have a lot of different options. The easiest one is just the manual scale. You can also automatically scale based on CPU. I know they're adding some new features here in the near future that allow you to auto scale on other metrics, but there is certainly an existing option via APIs to scale based on external factors. Matt Stein actually has a really nice example of this out on GitHub. But basically, you can have a number of workers that are reading from a queue, and then as that queue depth gets to a certain level, you increase the number of instances so you can more quickly process those messages. This is actually one that's pretty near and dear to my heart. Nearly every year on Black Friday, we get an influx of orders, and each of those orders has to be processed and sent to the stores. There's no real bottleneck in terms of the store's ability to process them, but they just back up in the queue because we have a certain number of application servers, and we're more or less sized for the average case, not that Black Friday day. And every year we have an incident call, we get a bunch of people on the phone, get people to spin up some more application servers, and then the queue processes. With something like this, it would be a non-event. We could all go about our normal Black Friday day, application would scale up, process some messages, and scale right back down. And that's out there today. Like I said, it's on GitHub if you wanted to make use of it. The next one has actually gotten a lot simpler lately too, so dev prod parity. If you're developing on something that's incredibly different from where you're going to be deploying the app in the future, you're going to find things that don't work, and you're really breaking some of the feedback cycle that you want. One thing that's important here is, an important distinction is the difference between using cups and an environment variable. If you're depending on cups, your application will fail when you try to deploy it, versus failing potentially later with an environment variable. So as I mentioned, this has gotten a lot easier lately. It's an incredibly complex setup process. You download a single application, you run the plugin, and then you do cf dev start. I do have to warn you, after you do that, you're probably going to go make dinner or something, because it does take just a little while. But it's really easy. And it also justifies this very pretty picture. So basically, you've got your own PCF environment running on your desktop. And you can do many of the things you could do on a real PCF environment. Logging is not necessarily the most exciting of the factors, but anyone that's been in any sort of troubleshooting situation recognizes how important it can be. You do want to make sure you're not logging to the file system, but rather to a stream. And this really allows you a lot of flexibility in the future. One of the things that we noticed very early on at Home Depot is once you say that, people are like, I can just do system.out. I don't need to do any sort of complex logging. And that's really not the right answer. You don't want to be lazy. So you want to make sure you're using Log4j or any of the other frameworks that are out there, and then logging some sort of structured log that you can make use of. One example that we used recently, trying to chase down a specific order. Because we have a structured log, we can use a number of different filters to find exactly the failure reason and the order that was involved, and make use of kind of all the cool things that are out there for Splunk. Lots of ways to do this. So if you're logging to that kind of Firehose stream, you can pick things up with Kafka. You can enrich the data, you can manipulate the data, and then drop it to any one of the visualization or searching tools that are out there. And then the final factor, operational tasks. This is another one that I think people overlook at times. If there are things that need to be done as part of your deployment or as part of setting up your app, you want that to be stored in your repo. You don't want that to be a separate thing that's kind of a secret. I remember early on in my experience at Home Depot, we had a device that was called the mobile cart, which was effectively a portable computer with a boat battery that was mobile and pushed around the store. One of the developers on the team actually got an award for getting the application to compile off the trunk. I mean, that's a scary thing. Like, you can't compile without winning an award off the trunk. Like, how are you actively making changes to that with any sort of confidence? So this is kind of the thought there. Anything you need to make that application run should be part of that repo. One of the really obvious ways or examples of this is using Flyway. So if you're making database changes or if you're making schema changes, things like that, Flyway makes it very possible for you to include that with your repo. And as you do your deployment, it can validate that the schema is correct, or it can update the schema to match what you need. By doing that, you make sure that the application works and that any future deployments of that application will include the necessary schema changes. And that's all I have for the 12 factors. Any questions or anything that I skimmed through that you'd like to know more about? Yeah, go ahead. Yeah, so going back a few slides to the get info. Wow. Yeah, so there are a couple different ones out there. The one that I've got a link to at the bottom, I think is referenced in the Spring documentation. The one up at the top, which is nearly the same thing. I think that guy and I read the same article as one that we published on Home Depot's GitHub. But all it does is take the get information, drop it into a properties file that gets picked up by that actuator. So lots of options. I think with Maven, it's actually a more official plugin that you can grab as well. Yeah?
So of these 12 factors, for those of us who aren't doing all of them,
Yeah.
which one is most important, or which one?
Sure. The naive answer is all of them are super important, and you're a bad person if you're not doing them all. But having said that, I really feel like configuration is probably the one that has burned me the most in the past. So having the configuration externalized gives you so much flexibility. There's nothing worse than realizing you're going to have to force a deployment during the middle of the day when you need to make a very tiny change. Having that externalized makes things so much easier. So maybe somebody typoed something, maybe, I don't know, something changed, but it lets you have a lot of flexibility. The scaling piece is also important, but it's a rare circumstance. I think we've all had bad deployments where being able to change a configuration would have made everyone's life a lot easier. Any other questions? Yeah. Yeah, backing service? No problem. The auth example? Oh yeah, so you can actually see most of the code there. Let me see if I can get out of, well, I'll talk to it and then I'll see if I can get out. So I've done two things here, right? One is I've added the dependency for the Spring security. And then at the bottom, you can see the top part of the code. Unfortunately, the slide's a little small. But basically, I'm just adding an authorization extractor. And that's in the main controller. Let me see if I can tab out. And I'll open up IntelliJ real quick. Actually, you know what? I've got that in GitHub. That'll be faster. I can find the window. Yeah, no internet. All right, so let's just go back to the slide. So you can see there I've got the authorization extractor. Underneath there, there's a override of a configure method. And basically all I've done there is said, for these specific endpoints, you need to have authorization. And then the authorization is actually coming here. You can see I'm grabbing a map from that OAuth provider. And basically I'm just looking, does this organization match the list of organizations that should have authorization? And that's literally all the code you need to write. My Angular application is what's referenced in the code below. And it basically just shows, here's the, I guess, different routes. And certain routes are public and aren't requiring authorization. But the main application requires authorization. And as soon as you try to get to that page, you see the login. It's not tightly coupled with those URLs. So if you have to change the code, the controller is tightly coupled with the application, if you will, for the Angular app. Is that what you're saying? Right. No, that's actually why we've got the configuration here. So I've got these properties, an application properties, which is the access token URL, the user authorization, all these good things. So no code change. You would just change the properties there to reference the new authorization you wanted to use. In this case, I do have those URLs hard-coded, but you could very easily change that to a external property, like I did with the client ID and the client secret. Yeah, I mean, there's lots of ways to do this. This is a somewhat simplified example for how you can use authorization. If you're doing something more complex, you may want to have a separate authorization process. Yeah, the 12-factor doesn't require authorization to be done one way or the other. What the 12-factor is saying in this case is externalize the config and make the actual auth process a separate backing service. How you do that is really up to you. Sorry, in the back?
What was the benefit you were looking to get by sending more messages to Kafka or managing your
I think there's a couple different things that we're doing in Kafka. One thing is cleaning up some of the information. So in some cases, doing DNS resolution, putting in the right information there. In some cases, it's adding correlation IDs. So if we've logged, say, a 20 kilobyte XML message, breaking that up because Splunk's not going to be happy with us, and then having correlation ID. There's lots of other things you can do there. I think we're really just kind of scratching the surface. Potentially, you could also use that to create events other places. So based on that log, send something to PagerDuty or do something else of that nature. Oh, Josh? That's a good question. So what tools do we use and what's our process for release management? I'm going to pick a single application team for this, but in general, we're still using Jenkins just because it's easy. So from a release perspective, we've got a number of different life cycles. Typically, we push to the staging environment based on the developer moving the task to finished. The product owner or QA at that point would validate with the dev that things look good, and they would accept the story. That would automatically kick the release to the next stage in the lifecycle, which for us is the kind of either blue or green, depending on what we're doing. And then at the point that the product owner feels good about that becoming the official release, we'd switch that over. Primarily, it's making use of Jenkins from a CI/CD perspective, GitHub from a source control perspective, and then Sauce Labs plus a few other tools from a QA perspective. Did I answer your question? Anyone else? Yes.
So you're talking about config server here and also showing that refresh endpoint. Is there like an example? I've seen that diagram.
Yeah.
Displayed a couple times. Is there an example of something like this working? Or
Yeah. So if you go to spring.io, there's actually a really nice example of using config server. I think both there as well as in GitHub, looking under Josh Long or Matt Stein, they both have some good examples out there using the full example. Yeah. Anyone else? All right, thanks. I really appreciate it. If you do think of any other questions, certainly feel free to hit me up on Twitter. I know they'll be posting the video and the slides online as well. Thanks.